Okay, after that we will start our mm, just give me a second. Yeah. Okay, so I just brief you about the lab. Okay, so basically in the lab there are total 6 experiments. Okay, for each experiment you have to do two things. One is the LT spice. I don't know how much of you are aware about the LT spice, but that is a simulation tool. Okay, simulation tool for electronic circuit. Okay, so you have to that particularly, like for example I am giving you one circuit, any circuit I just give you in this way, or I give you this circuit. Okay, now we are telling you what is the Vi, we are telling you what we require the V out. Okay, so on the simulation of LT spice software you have to find the value of resistance and capacitance. Okay, so for which V out, like for example we are giving you my, this is the Vi. Okay, and any particularly V out I am just giving you. Okay, or I just tell you that this is the V out voltage, or basically what we require. Now on the basis of that one you have to calculate the value of R and C. Okay, how you calculate that one? Because in the analog you already cover that particularly part. Okay, so there are some formulas we will discuss. Okay, there are some formulas we will discuss. On the basis of that formula you calculate the value of R and C. Now use that R and C value in this circuit and check that V out is similar to the desired V out or not. Okay, if V out that you are getting is equal to the desired V out or not. If V out is not equal to desired V out, okay, you have to change or some minor changes done in the value of R and C. Okay, this is the approach you have to do in the LT spice. Now after that you basically got the value of R and C. Now you have to make a circuit on breadboard. Okay, make a circuit on a breadboard. Clear? Any doubts? Now for create a circuit on a breadboard, some components are required. I already shared you the list. Share the list of component that is required to execute experiment 1 to experiment 6. Okay. Now after that what you have to do? You have to create a folder on a drive. Okay, like for example you have to create a one folder on a drive with the name of week 1. In this week 1 folder you have to upload 3 files. One is the report, second LT spice circuit, and third a video of circuit with explanation that you have done on a breadboard. Okay, that means a video of circuit, breadboard circuit with explanation. Is it clear? So you have to upload these three files. You have to basically create these three files, put in a folder week one. Now this folder link you have to share. Okay, this folder link you have to share. We will circulate a Google form with you. In this form, you have to share this link. Now, if you have any doubt, you can ask.
Sir, how we will calculate R and C?
Like for example, we have a VEI, we have a V naught. Okay. Similar, I just take one example is that this is my circuit. Okay. Positive feedback, positive VI. Okay, we are using this V naught. Sorry, that is grounded. This is the V out. R1, R2. Okay, I give you that we are apply a signal, sinusoidal signal that is having a voltage of 2 volts and minus 2 volt, and we are required a output voltage that is having a signal from minus plus minus 5 to plus 5. Can you calculate the value of R1 and R2? Okay, because you know this is the positive non-inverting amplifier, so V naught upon Vi is what? 1 plus Rf by Ri, or R1, R2 by R1. In this circuit, R2 by R1. Now what is V naught? If I'm taking that is of 10 volts, that is 4 volts, so V naught upon Vi is what? 10 divided by 4, or I can take 5 divided by 2, any value. Okay, that is equal to 1 plus Rf by R1. So 2.5 is equal to 1 plus Rf by R1. Okay, so Rf by R1 is what? 1.5. Okay, now you can choose the value that is in the this circuit. This is the R2 by R1, that is 1.5. If I choose R2 is equal to 1.5 times R1, if I choose R1 is equal to 10k, so my R2 is what? 15k. Okay, or I can choose my R1 is 1 kilo ohm, so my R2 is 1.5 kilo ohm. So which resistance you have, according to this one you can choose the R1. According to that R1, automatically R2 is 1.5 times of R1. Okay, so now I just take that what is the value of R1 and R2. Now what I do, in the LT spice I create this circuit, use the value of R1 and R2, this one. Okay, and check the output is correct or not. You are getting the correct output. Okay, so you calculate the value first by the formula, Then after using the LT spice, verify that these values are correct or not. And finally, after you are in the LT spice, it is basically verified that the value R1 and R2 you chosen is the correct. Now you create a circuit on a breadboard. Okay.
Okay, sir.
Excuse me, sir. I have a question.
Yeah.
Sir, this is regarding the analog lab that just concluded a few days ago.
Wait a minute. What you are saying?
Sir, this is regarding the lab that just ended a few days ago on campus. Sir,
Wait a minute. I am unable. Just use. Wait a minute.
Sir, I wanted to know the grading. Will that 40% minimum?
Wait a
will be
minute. Wait a
based
minute.
on-
Don't wait a minute. Just give me a second.
Okay, sir. I'll just type it out.
Yes. Now tell me, Rohan.
Hello, sir. Can you
Yeah.
hear me?
Yeah. Now I can hear you.
I was asking that the final grade condition that 40% weekly experiments should be done. Will that be based on the first 5 experiments?
Yeah. That is on basis of the 6 experiments.
And after that, the best 4 will be taken for 40%.
Yeah.
Okay.
4 out of 6.
Yeah. Okay. Thank you, sir.
Any other doubt?
Yeah, just one question, sir, if I may.
Yeah.
For the experiment, I mean, for carrying out the experiment on a breadboard, we will be using the analog devices kit that we had
Yeah.
purchased.
ADML kit
Correct.
you required for that one.
Correct. But the limitation there is that it does not have a positive negative supply. So we experience this difficulty in foundation also. So
Okay.
it will have to be, all the experiments perhaps would have to be from 0 to 5 volt within
Okay.
that supply voltage by creating an offset.
Okay.
So that should be okay, right?
Yeah, no problem with that one because actually we are using the MCP 6004. Okay.
Yeah.
That is the operation amplifier. If you see the list that I shared on the
Yes.
drive,
Yes.
okay, basically that is use the MCP 6004. So this is the advantage of the MCP 6004 is that is a single supply operation. So we not require the +5 and -5, yeah, or plus VCC or minus VCC. We only require the VCC and the ground.
Right.
Okay. So
Yeah.
we choose the component in a way that that will be basically done by the ADML kit.
Yeah. Okay.
And all the component will be on that one.
Yeah, and one more question.
Yeah.
If we find a difficulty getting this microchip part number of the, I mean, the operational amplifier that you have suggested,
Mhm.
will it be okay to go with something like LM324, which would be very, very commonly available?
Yeah, that is the thing is that some particularly operation amplifier that is available in the market that will be operated in the dual supply. This is the first thing. Okay, second thing is that MCP 6004 is the noise is very less in that one. Otherwise, you basically if you go with the experiment, so somehow we can use the experiment one into the experiment. Basically, we are giving the output of experiment one into the experiment 4, 5, 6, anyone. Okay, so if we are interfacing that particularly experiment one with the other experiment, so because of the noise you are not getting the correct output. Okay, so this is the problem that you are facing. Okay, because this problem is also facing by the previous batch also. So I just
Okay.
recommended you can use the MCP 6004. Okay, if that is not available in any certain cases, so you can use the other operation amplifier, but you have to compromise with the some noise part.
Okay. Understood. Thank you.
Okay. I think MCP 6004 you can easily purchase from the internet. There is a robo.in, I think that will be provide the MCP 6004. or Mauser will be provided that MCP 6004.
Okay.
I think I have one student number also who will be providing you the complete kit for that one.
Okay.
Anything else you want to ask about the lab part?
From my side, that was all.
Okay. Anyone other? Any doubt related to the particular lab you can ask.
Sir, when is the deadline for the first experiment?
I will share the complete deadline when the list is final. Okay. I
Okay.
just share all the particular deadline that when the week one experiment will be released, when the week one experiment submission date is that. Okay, so in that particularly, everything will be mentioned.
Sir, what if the deadline is before the re-registration?
No. That is after.
Or that will be after the
Yeah,
re-registration,
yeah,
right?
yeah. Yes.
Okay. Thank you, sir.
Anything else? Uh, Alkesh, you can do one thing is also that in the group you can ask because Victoria ma'am is also there who will be handling all these things. So by tagging them, you can ask that what is the process of re-registration and when the re-registration will be start.
Okay, sir. But sir, I've mailed them many times in the
You
email.
can chat in the group because in that particularly group all will be available. Okay, so they will reply for that one because
Okay, sir.
lots of the mail are coming on the support and as well as on their mail ID. So maybe they forget about that one. But if you can put in the group, so they will tell you.
Okay, sir. Okay. Thank you, sir.
Anything else related to the lab part? Anything else? Okay. So now if you have any doubt related to the week one and week two assignment, someone send me that particularly this question. Okay, so VI, that is V out. Okay, this is the VE, this is the A time VE. Okay, this is the beta time V out. Okay, so this question is given in the graded assignment, and now if we draw the equation of that one, so we have a two different equation. One equation is what? V out is equal to A time VE. Okay, this is the first equation. And if we are talking about the V, what is the V? V is equal to Vi minus beta time V out. So V out is equal to A time Vi minus beta time V out. Okay, the question is, just wait a minute. Yes. Consider the negative feedback in both A and which of the following is wrong. Okay. Now it is a E. They mentioned the E. So it is a time E. Now the 4 options are given for that one. I will just copy and paste 4 options. Okay. So yeah. Now if I say that there are two particular terms is created, E is equal to Vi minus beta time V out. Okay. So if we go that, if V out increases, we can say E decreases. Okay, because V out is increases, so this particularly component will be increased. And if this component will be increased, the overall E will be decreased. Okay, so this is the first condition. Second, if you see the other equation, the other equation is what? V out is equal to E times A. This is the second equation. According to this equation, if E increase, V out increase, or V out increase, E increase. Okay, so there are the particularly two condition in this. Particularly, if we go with this part, equation number 1, we can say if V out increase, E decrease. This option is correct. Or second is if V out decrease, E increase. This option is correct according to the equation number 1. Okay, but according to the equation number 2, we can say V out and E both are directly proportional. So that means these two will be correct, this one and this one, according to equation number 2. Any doubt? Any doubt?
No, sir.
Okay. Now, in the answer, these are the false statement and these are the correct statement. Why? The basically thing is that in the equation 1, E is not directly dependent on the V out. Basically, in the equation first, E is the function of V in as well as V out. Okay, so we can't say that E is directly proportional to V out. E is directly proportional to V out. We can't say this thing. Okay, so according to equation 1, we can't say that what is the relation between V out and E. Either the V out will increase or decrease when E increases. Because here the input VI is also variable and V out is also variable. Okay, so basically E is function of V in and V out, two variables. Okay, so according to this one, these two equations are false. These two are statement are false. Okay, now if we go with the second statement, so V out is directly proportional to E. Why? Because A is the amplifier gain and that is the constant. Okay, that is the constant part. So from the equation 2, we can say the V out is directly proportional to E. So that means if E increase, V out increase. So that means equation number first and fourth are the true statement. Clear? So why we choose this particularly option? Only because of this statement.
Sir, I have marked the same option, but I have got
Which one? Which option you mark?
the first and fourth, sir.
First and fourth. But these are the true statement. I am in the question I am asking which are the false statement.
Okay, sir.
Okay, which are the false statement. The false statement is which one? Second and third. Any other doubts related to the graded assignment 1 and 2?
Yes, sir.
Yeah, tell me.
So week 2 graded assignment, question number 12.
Week 2 graded assignment question number 12. Yeah. Is it?
Yes, sir.
Okay. Now, if I see the feedback, okay, first of all, I see the feedback. So, what can I do? I just break a loop, increase the voltage. Okay, so the voltage will be go in this part. So, this particularly operation amplifier is the, like for example, the voltage is increases, the voltage is increases, multiply with negative, that means voltage is decreases, downward direction. Okay, so second amplifier is basically operation amplifier is the in the negative feedback. Now we check the first amplifier, so voltage increases, that means voltage increases, voltage increases, voltage increases. If it's multiply with the negative, so that means downward direction. Okay, downward direction, downward direction. Multiply with positive, that means downward direction. And here we are also getting the voltage in the downward direction. That means both op-amp will be working in a negative feedback. Clear?
Yes, sir.
Now, if we have a 2 kilovolts, okay, and this is my 2 kilo plus minus This is V out. Okay, because no current will be flowing through the operation amplifier, current will be going with the feedback circuit, the current will be getting at the V out. So that means second amplifier doesn't create any effect in the output voltage. Okay, this is the 2 kilo ohm, 5 kilo ohm, and here we have one more resistor, that is the 8 kilo ohm. So because of this 2 kilo ohm that is connected on a non-inverting terminal, what is the output? Vi 1 plus Rf by R1. Okay, so Va out is equal to 2 volts 1 plus 8 by 5. That means 2 volt 1 plus 1.6. So 2.6, that means 5.2 volts. Okay, our output voltage is 5.2 volts. Now we consider the second operation amplifier. This is the plus, this is the minus. We are getting 5.2 volts here. This is the 20k, 4k, ground. We have to calculate the voltage here. Okay, we have to calculate the voltage here. So why this voltage will be appear? Because of this 5.2 voltage, the current is flowing in this direction. Okay, this is the direction of current. Now if the current is flowing in this direction, that means some drop will be across the 20k and some drop will be across the 4k. So the drop across 4k is we are getting at this point. Okay, and because of negative feedback, this voltage and this voltage is same, so we are getting the Vx and Vx. Okay, now how we get the Vx voltage? If 5.2 current will be draw, this is the voltage. So can I apply the calculate the current? So 5.2, this is the ground, minus 0 upon resistance is 20 plus 4, 24k. This is the current I. Okay, and what is the voltage of across 4k? So V at 4k is equal to the current that is flowing 5.2 divided by 24k into 4k. So cancel out these two, that is 6. So V at 4k is what? 5.2 divided by 6. 0.864. Okay, so Vx is Vf4k is nothing but Vx. Okay, and the Vx that is equal to this one, because virtual ground condition we are assuming that the positive terminal voltage is equal to the negative terminal voltage. Okay, and both is equal to the Vx, that is equal to 0.86. Okay.
Yes, sir. Thank you. Got it, sir.
Yeah. Any other doubt? Any other doubts?
Sir, GA2 question number 10, sir.
GA2 question number 10.
Inverting or non-inverting?
I think we have already solved this type of question. This one. Okay. So
Yes.
basically, we have to identify where we are getting the maximum voltage that will be behave as a non-inverting terminal. Okay. Which particularly, if we are consider, like for example, if I'm considering this is the positive terminal voltage and this is the negative voltage. Okay, this is the positive terminal, negative terminal. If positive terminal voltage is greater than negative terminal voltage, okay, so what we are getting here, that is equal to V positive minus V negative, that is positive. Clear? So if I break the loop, increase the voltage, and according to this one, if I am getting the positive terminal voltage is greater than negative terminal voltage, so we are getting the output voltage is also in the positive direction. So that behave as a positive feedback. Okay. Similarly, if I consider that negative terminal voltage is greater than positive terminal voltage, so V positive minus V negative, that will be behave as a negative voltage. Okay. So what we are getting in the output, we are getting output the negative voltage, that means downward direction. Less than 0, that means downward direction. So in this case, we are getting the negative feedback. Okay. Any doubt?
No, sir.
Okay.
Where
Now we have to solve. We have to solve. So how we solve that one? If I say that this is the V naught, okay. So first of all, I consider this V naught voltage will be flowing through this one. So the direction of current is this one because V naught to the ground. Okay. So what is the voltage is drop across this one is V naught by 2,
Yes, sir.
and what is the voltage drop across this one is again V naught by 2. Okay, so I just consider that this is the terminal 1 and terminal 2. Okay, so at terminal 2, the voltage is V is V naught by 2.
We not by 2.
Okay, why? Because this voltage is just similar to the voltage difference between this one and this one. Or
Yes, sir.
basically the voltage drop across this resistor. Okay, now similarly, if I take the terminal 1 voltage, so that V naught and this voltage is also add. Okay, and complete voltage will be drop across this resistor. The terminal 1 voltage is what? V is V naught plus 5 volts. Why? Because this particularly is connected with the negative polarity. So like similar to this, say that we are having a one particularly negative positive connected with the ground. Again we have a negative positive. Okay, this is the V1, this is the V2. So overall voltage we are getting across this one is what? V1 plus V2. So similarly V0. So V0 is in this way. This is the V0. Okay, so if the current will be flowing in this particularly branch, so this is the polarity is connected positive to negative, that means these two voltage will be added and all voltage will be drop across 10 kY because the second terminal is the grounded. Okay, so terminal 2 voltage is what? V0 by 2. Terminal 1 voltage is V0 plus 5. Which voltage is higher?
Terminal 1.
Terminal 1. Okay, so V1 is greater than V2. So that means if we have to maintain this one in the negative feedback, the condition is what? the negative terminal voltage is greater than the positive terminal voltage. Okay, so which one is higher? V1 is higher. So this is the negative terminal, this is the positive terminal.
Minus RF by R.
We are not calculating this one. We have to identify that 5 volt is connected to which terminal. So 5 volt will be connected to the negative terminal, inverting terminal. Clear?
Yes, sir. Yes, sir. Clear.
Now if we have to calculate the V naught, how we calculate? We know that terminal 1 voltage is equal to terminal 2 voltage because of the negative feedback. Okay, mentioned in the question, it is a negative feedback. In the negative feedback, the V1 is equal to V2. What is the V1 voltage? That is the V naught plus 5. And what is the V2 voltage? That is the V naught by 2. Okay, so if I take this one, this side, and 5 is this side, so V naught minus V naught by 2 is equal to minus 5. So V naught by 2 is minus 5, that means V naught is minus 10 volt.
10.
That is the question number 11. Okay.
Yes, sir.
Any other doubts? Yes, any other doubts? So in the last class, I think we go through with the week 3 content summary. Okay, so we discuss the single supply operation, then dual supply operation. Then I think we are going to the known identity in op-amp. Any idea how much part we will cover? Anyone, any idea? If anyone attended the last class, so can anyone tell me how much we cover? I think before the paradox. Okay, so no idea. So just give me a second. Okay, till then using of capacitor. So I think we go with the known identity of DC. Okay, so now for the single supply operation, hello, wait a minute actually. My pen tab is stuck.
Sir, we
Yeah.
can't hear you.
Wait a minute. I'm just not. Hello. Hello, can you hear me?
Yes, sir, you are audible.
Okay. Yeah. So in the previous class, we are discussed that single supply operation we required some voltage ups basically to enhance the positive and negative feedback terminals. So if we have this is my operation amplifier, I can use this is the plus minus. This is the resistance. So what I do, I have to require a VCC by 2 voltage. Okay, and similarly for the ground also, we required VCC by 2 voltage. So my output is what? V0 plus VCC by 2 because of the single supply operation. This is the VCC and this is the ground. Okay, so we have discussed this thing. Now to remove this particularly VCC by 2 terminal, what should I do? I have to apply this VCC by 2 with the opposite polarity. So here if we are getting the output voltage, so that is the V0. Okay, now the thing is that from where we are getting this VCC by 2. Okay, so the one way is that we require the Vi signal. We use this particular resistance. Here I just use the VCC resistance R1 and R2 that will be connected on a positive terminal. In the negative terminal, we are using the resistor, then supply. To get the V0. Okay, so here we are connected to the VCC and here we are connected to the ground. This is the one option. But what is the problem? The problem is that we require two different voltage source in a circuit, Vi and VCC. Okay, Vi and VCC. These are the two different supplies we required for in this circuit. Now, if I use, so the thing is that from the 220 volts, I have to convert into the 9 volt or 5 volt. Now we have to convert this AC signal into the DC signal. Okay. Now, second thing is that I required one more particularly circuit to convert into the VI. Okay, and from that VI either I can use as a DC or AC circuit. So we required one circuit this one and one circuit this one. That is the VCC and that is the VI plus. Okay. So this is the problem that we required two different supplies. Now we convert this AC signal into two different supplies. That is a quite typical and the complex. Why? Because in a single circuit, two different supplies, chances of that they may get short. Okay. So to overcome this problem, what we do? We are required a capacitor in place of supply voltage. Okay, we required a capacitor. So what we do? We have this Vi this resistor, this capacitor, positive terminal, negative again ground, Ri, capacitor, it is capacitor and Vout. Okay, so we can convert our circuit in a way that means in place of VCC by 2, I use a capacitor. That capacitor will store charge and use as supply source of VCC wire. Clear? Any doubt in that one? So we already discussed this thing. Now we have to check that what is the capacitor condition. Capacitor consideration. The capacitor consideration is that what is the capacitance value we required to store VCC by 2. Okay, this is the first condition. Second, if we use a capacitor, so we have to maintain charging and discharging time also. Okay, what is the meaning of maintenance charging and discharging time? That means top charging is not very small, as well as top discharging is also not very small. Sorry, top charging is not very large. This is the consideration. Okay. Second, the problem is that op-amp offset voltage. What is the meaning of op-amp offset voltage? When operation amplifier works in differential mode, okay, in that scenario, without apply any input voltage, we are getting some output voltage. Okay, we are getting some output voltage. So basically, if we are saying that V out is what? A time V in 1 minus V input. Okay, so what is the meaning of differential mode? If we have a operation amplifier and if we apply the input voltage on both terminal V in 1 minus V in 2, So this is called the differential mode. Okay. Now the thing is that if V in 1 minus V in 2 is 0, that means the voltage applied at input is 0. Okay. So if V in 1 minus V in 2 is 0, so V out is A times 0, that is 0. Okay, that is 0. But this is the ideal case. But practically what happen? V naught is not equal to 0. V naught is not equal to 0 because of some error voltage. Because of some error voltage. So to maintain a VO of 0, we apply some voltage at input terminal. This applied voltage is called the offset voltage. This applied voltage is called as the offset voltage. Okay. Now how we check what is the offset voltage? We have to apply the offset voltage in positive or we have to apply the offset voltage in negative. That all will be decided on the basis of output voltage. So V out is what? A time V in 1 minus V in 2. Okay. If our V out is positive, that means we assume the VA1 is greater than V in 2. Normally we are assuming that V in 1 is equal to V in 2. So to compensate this positive voltage, we have to reduce this voltage so it becomes a 0. Okay, V out is positive. So what we have to do, we have to choose that A time V in 1 minus V in 2 minus V offset. Okay, because if V out is positive, that means this parameter is positive. V in 1 minus V in 2. This parameter is positive. This parameter is positive. A is the normally gain. Gain is always positive. So basically V in minus V into is positive. Positive multiplied by the amplifier gain, we are getting the output voltage is positive. So we have to reduce this value. Okay, so what should I do? For reducing, we just subtract some more parameters. So this value should become 0. This value is 0, and if this value is 0, so A times 0 is equal to 0. So V out is 0. And if V out is negative, so what we do? That means this particularly value is already negative. So to compensate as a 0, what should we do? We have to add something. So V in 1 minus V in 2 plus V offset. Okay, V in 1 minus V in 2 plus V offset. So we have to add this value. So if this value is negative, so after adding something, this value becomes 0. 0 multiplied by A, that is 0. So my V out is 0. Okay.
Yes, sir.
So after adding the offset voltage, I just say my almost circuit should be like that. This is a V naught, positive terminal, negative terminal. Okay, so if this is the V in 1 and this is the V offset, so here we are getting as a V in 1 minus V offset. Okay, and this is V2. So what is the V naught? V naught is the difference between these two. So V in 1 minus V offset minus V2 times A.
Yes, sir.
Okay, and what is the effect of this one on the characteristics? The characteristics is also changed. Okay, so initially if I say if this is my VA1 minus V2, okay, and this is my output voltage. V out. So as V in minus V2 will be increased, output voltage is also increases. Okay, and the slope of this one is basically A. Slope of this one is A. Okay, so I just draw this characteristics. Okay, so this is my characteristic. Now the thing is that why it is constant.
VDD and VSS.
Yeah. So basically the condition is that my output voltage is always lies between VCC or VDD and VSS. Okay,
VSS.
it never goes beyond that one. So if I change my V1 minus V2, if I increase my V1 minus V2, like for example, I apply VCC 10 volt and minus 10 volt. Okay, and if V1 minus V2 is 6 volt, okay, the amplifier gain is 10. So what is the output?
60 volt, not 60 volt.
Yeah, so
Saturated
basically
minus.
if I calculate with the formula, so V naught is nothing but 10 times 6, that is 60 volt. But we know that V naught will not exceed beyond the VDD. So
So it
V
will
naught is equal to plus 10. Okay, if I increase the VI by VN as a 7 volt, 7 multiplied by 10, 70 volt,
70.
but it will be V naught is a constant. So if after a certain limit, if I increase my VI, V1 minus V2, my output will be constant. Okay, and this constant voltage is equal to the VCC. And similarly for the negative direction, it will be constant, and that voltage is called the VSS. Okay, now the thing is that if actually V in minus V out is 0, V1 minus V2 is 0, but because of some particularly non-identity available in the operation amplifier, we are getting output voltage. Okay, we are getting the output voltage. So V out is not equal to 0 because of some error voltage or non-identity in the operator. So we have to reduce my voltage by V offset. So when Vi minus V naught is 0, but practically this is not 0. Okay. So this is the graph. This is the graph because of this non-identity. Okay. So if V1 V in V1 minus V2 is positive. Okay, V1 minus V2 is positive. So V naught is also a times V1 minus V2. That is also positive. So basically, if V1 minus V2 is 0, we are getting V naught is a times V1 minus V2, but that is not equal to 0. So you can see V1 minus V2 is 0. So V1 minus V2 is 0, but V naught is not equal to 0. Okay, V1 is not equal to 0 at this point. So V1 and V2 should be 0 when V1 minus V2 minus V of is 0. Then V naught is 0. Okay, V1 minus V2 minus V of is 0. Then V naught is 0. So that means the V1 minus V2 is what? V of. So this point is called V of. Okay. So V1 minus V2 is V of, then V naught is 0.
Yes, sir.
So this is called the V. Okay. Now Vi, this is the plus minus connected on it. Operation amplifier plus. This is the R, this is the MR. Okay. So because now if we say that if the resistance ratio is RF upon R1 is 1. Okay. So because of this non-ideality, that is the voltage is less. Okay, very less voltage in millivolt or something. But if R1 upon RF upon R1 is 1, if the ratio RF upon R1 is increases, this output voltage V out voltage is also increases because of V offset. Okay, because of V offset. So if we say that if the value of this one RF upon R1 is M, so if M is very high, so because of this output offset voltage V out is also very high. Okay, so that particularly create a non-identity. Now, in this way, can you calculate the output voltage? So my input voltage is Vi minus V of set, and the gain is 1 plus MR upon R. Okay, so this is the Vi minus V offset 1 plus M. Okay, so Vi 1 plus M, that is the output voltage, minus 1 plus 10 times V offset. That is reason is because of non-identity. Yes, what are you saying? Any doubt?
No, sir.
So these are the known identities. Now, second known identities in the operation amplifier is finite output resistance. Okay. What is the meaning of that one? Finite output resistance. We know that R in is basically infinite and R out we are taking as a 0. Okay, we have already discussed this thing. So this is the resistance V1, V2. So what we assume in the this one, the current is 0. Input current is 0. So the what is the meaning of input current is 0? That means this particular resistance is a open loop, open circuit. Okay, so if there is a no path will be flow, that means current is 0. So that particular resistance is R in is very high. Okay. Now, if we are taking that ideally, R in is infinite. But as we know, infinite is not possible. Okay, so practically
Very high.
Rn is high. Now the thing is that I just clear you that if Rn is high, so that doesn't mean, like for example, if I say that Rn is 2 mega ohm, okay, so don't be confused with that. Sir, Rn is not a infinite, so this is a non-ideal op amp. No, this is the ideal op amp. Ideal op amp till the response of op amp response is not dependent on frequency. Okay, that response is not dependent on frequency. Till that, this particularly op amp is ideal op amp. But in the ideal op amp also, the R in value is high. That is the practical case. Okay, whereas it is infinite for the ideal case. Okay, so don't be confused that R in value is not infinite, so this is a non-ideal op amp. If R in value is high, so this is the ideal op amp. Now, this is grounded. Okay, this is the A time V1 minus V2 and R out. Okay, so the current that will be maximum deliver at the output side only in the scenario is that R out is equal to 0. Okay, R out is 0. But again, that is the ideal case. In the practically, R out is minimum. Okay, R out is minimum, but that should not be equal to 0. Okay, I think you are aware with the different type of materials. 3 type of material are available: conductor, semiconductor, insulator. Aware about this one?
Yes, sir.
Conductor is where resistance we can say it is zero. Semiconductor insulator where the resistance is infinite, and semiconductor where the resistance lies between the less than to the insulator and greater than to the conductor. But R is equal to 0 is not possible. Okay. We can reduce, we can minimize the R minimum value, R value. Okay, like for example, we are using the copper. The R is less, but not 0. Okay. Boom. If we go better conductors, so we can use the gold. Again, R is less, but not equal to 0. Okay. Only some materials are available where the resistance is 0, and that is not a material, that is a property of the material. This is called the superconductor. Superconductor. I don't know you heard this name. Okay. That is the property of the conducting materials. In some condition, the conducting material shows the property that resistance is 0, but only in some condition. Like for example, maybe the pressure condition, maybe the temperature condition. Okay, so some material shows the resistance is 0 for a temperature of -40, -50 degrees centigrade. Okay, so that is the property of that materials. Okay, so they show the resistance value 0 at some certain condition. So this is the superconductor. But practically, that particularly superconductor material also doesn't show the resistance for all that temperature. Okay, so similarly, if I say that R out is 0 ideally, okay, if I am taking the wire also, the wire also has some resistance. So ideally case the R out is 0, but practically R out is minimum. Okay, so that means we have a circuit. So this is the internal resistance or internal output resistance. Internal output resistance of op-amp. Okay. Now if the current will be flowing, so the total resistance value is what? If I say the current will be flowing, so this is the overall resistance that will be available in the path of current. Okay. So if you calculate the voltage at this point, what is the voltage? I say RF is MR and R1 is R. Okay, so this point voltage is, because of this voltage V out, the direction of current is this one. So the overall current is V naught upon MR plus R. Okay, so V naught upon M plus 1 times R. And if we have to take the voltage of this point Vx, so what is the Vx? Vx is V naught M plus 1 times R multiplied with R. So R and R will be cancelled out. So that is equal to V naught M plus 1. Okay. Now, if this is the voltage at this point, we are getting the voltage at this point is what? Sorry. V naught M plus 1. Okay. Now, can you calculate the output voltage?
A times V.
Vi minus V naught M plus 1 times A.
Yes, sir.
Okay, and what these are the three resistors are also available. This is the output voltage at this point. VA, I am just saying that. So VA is what? VI minus this voltage they multiply with A. V1 minus V2 multiply by time. This is the VA. Now what is the V naught? This VA will be passed across this particularly path. Okay, so the voltage drop at this point is what? V naught is equal to VA
Minus V out.
Y minus V out. VA times M plus 1 R upon R naught plus M plus 1 time R. Can I explain it?
No, sir. No, sir. Current voltage division.
Voltage divider, apply the voltage divider. So the drop across this R naught is VA is the input voltage. The voltage drop across this one is remaining voltage. Remaining particularly, sorry, V naught is what? The drop across RF and R1. So that is M plus 1 times R into total resistance R naught plus M plus 1 time R. Okay, if you put the value of VA, so V naught is equal to VI minus V naught time M plus 1 A into M plus 1 R upon R naught plus M plus 1 times R. Okay, and in this way you can say, if you solve this one, so take the V naught term here, then again V naught upon Vi. Okay, so I just V naught upon Vi is somehow A into M plus 1 R divided by R naught plus M plus 1 times R whole divided by, if we take the LCM, so R naught plus M plus 1 times R multiply with A into M plus 1 time R. M plus 1 R into, so 1 plus 1 plus AR M plus 1 and M plus 1 will cancel out. Okay, and this is the LCM we are taking. So this is the term divided by R naught plus M plus 1 times R. So these two terms are cancel out. So that is A upon M plus 1 times R. I think this is the value. Okay, you can check from the video. I think this is the value. Okay, so if R naught is not available, so basically R naught is 0, so V naught upon Vi is what? A into M plus 1 times R. Now this R naught is 0. So M plus 1 times R, 1 plus AR upon 1 plus M time R. Okay, so these two cancel out. V naught upon Vi is R and R cancel out. If I take the LCM, so A upon 1 plus M plus A. Okay, so this is the A upon 1 plus A upon 1 plus. Okay, and if I can say that this is nothing but equal to A upon 1 plus A beta. Okay, this is the formula. Feedback form. This is the formula. If we have we already discussed this formula. This is the A beta minus plus V out
Yes,
V
sir.
in. So V out upon V in is what? A upon 1 plus
Plus AB.
A beta. Okay, so that is in the similar form. So V naught upon Vi is A upon 1 plus A upon 1 plus M. So beta is what? 1 upon 1 plus M.
1 plus.
Feedback. Okay. But because of this R naught, my formula will be replaced in this one. Okay, now the thing is that if R naught is increased, so this component will decrease. Okay, this component will decrease, and because of this component, and here the R naught vector is increased. So denominator term complete will be increases. Okay, denominator term will be increases. So we can say the V naught upon Vi is decreases as R naught increases.
Yes.
Okay. So if R naught is 0, V naught upon Vi is maximum. But that is not ideally possible, practically possible. So as R naught is increases, V naught upon Vi is reduces. That is the non-linearity. So non-ideality. Non-ideality. Due to input resistance. Sorry, not input. Output resistance. Okay. So that is the complete part. Now, if you have any doubt, you can ask.
No doubt, sir.
So I think we will close here.
Yes, sir. Okay, sir.
Okay. So thank you all.
Thank you, sir.